Newton's law of motion. Newton's first law, or the law of inertia, states that an object at rest will remain at rest unless acted upon by external force. For example, a book on a table remains still until someone pushes it. An object in motion will continue in a straight line at a constant velocity unless acted upon by an external force. For example, a hockey puck sliding on ice will keep moving until friction or a stick stops it. Inertia is the tendency of an object to resist changes in its state of motions. For example, when a car suddenly brakes, passengers feel a jolt forward due to their inertia. The more mass an object has, the more inertia it possesses. For example, it's harder to push a full shopping cart than an empty one because the full cart has more mass. A stationary car will not move unless a force like a push is applied. For example, a parked car remains in place until the driver turns the key to start the engine and accelerates. A rolling ball on a frictionless surface will keep rolling indefinitely. For example, in a vacuum, a marble rolled across a perfectly smooth floor would continue moving until it encounters an obstacle. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. For example, pushing a shopping cart with one hand accelerates it faster than pushing it with two hands. This law is expressed mathematically as, for example, if you apply a force of 10 Newton to a 2 kg object, it will accelerate at 5 meter per square second. 10 Newton equals 2 kg into 5 meter per square second. F is force measured in newtons and m is mass measured in kilograms kg, and a is acceleration measured in meters per second squared. For example, a force of 1 Newton can accelerate a 1 kg object by 1 meter per square second. A greater force results in greater acceleration. For example, a stronger person can push a heavy box more easily and cause it to accelerate faster than someone weaker. A larger mass results in less acceleration for the same applied force. For example, when two friends push a large sofa and a small chair with the same force, the chair moves faster because it has less mass. Newton's third law states that for every action there is an equal or opposite reaction. For example, when you jump off a diving board, you push down on the board and it pushes you upward. Action and reaction forces always act on different objects. For example, when you walk, your foot pushes backward against the ground and the ground pushes you forward. For every action, there is an equal and opposite reaction. For example, when a car accelerates, the tires push backward against the road and the road pushes the car forward. A swimmer pushes water backward with their hands, action, and the water pushes them forward, reaction. For example, swimmers use their hands to propel themselves through the water, feeling the resistance of the water. A rocket launches upward by expelling gases downward, creating an upward reaction force. For example, when the engines fire, hot gases shoot out on the rocket's nozzles, propelling it into the sky. Understanding motion in vehicles, supports, and various machinery is crucial. For example, engineers design cars with aerodynamic shapes to minimize air resistance, improving performance. These laws can be used in designing structures and vehicles that can withstand forces and motions. For example, bridges are engineered to handle the weight of vehicles and withstand strong winds. Newton's law explains the orbits of planets and the motion of celestial bodies. For example, the Earth orbits the Sun due to the gravitational attraction between them. Following Newton's law, net force is the vector sum of the all forces acting on an object, determining its acceleration. For example, if two people push a car in opposite direction, the net force is the difference between their applied forces. Friction is a force that opposes motion, relevant in applying the first law. For example, a sliding book on the table slows down due to friction between the book and the table surface. Gravitational force is the force of attraction between two masses, significant in various applications. For example, apples fall from the trees due to the Earth's gravitational pull, illustrating gravitational force in action. Newton's law apply well to macroscopic objects moving at low speeds relative to the speed of light. For example, a soccer ball kicked on a field behaves predictably according to Newton's law. They do not accurately describe motion in quantum mechanics or at relativistic speeds near light speed. For example, at atomic scales, particle behaves differently than predicted by Newton's law. Newton's law were derived from experimental observations with various experiments demonstrating these laws in action. For example, Galileo's inclined plane experiments laid the groundwork for understanding motion. The concept of inertia can be observed in a moving bus. For example, passengers lurch forward when the bus suddenly stops because their bodies want to continue moving. A common example of friction is rubbing your hands together. For example, the heat generated by rubbing creates warmth due to friction opposing the motion of your hands. When you ride a bicycle, you apply forces to the pedal, which accelerates the bike forward. For example, the harder you pedal, the faster the bike moves, demonstrating Newton's second law. When a child swings on a swing set, they must push off the ground to gain momentum. For example, the action of pushing down results in the swing moving forward. A person diving into a pool displaces water as they enter. For example, the action of the diver entering the water creates a splash, illustrating the reaction of the water.